we're going to derive this. Now, what you see here is a product and a quotient both. Can we change it so we don't have to deal with a product and quotient both? Could I just simply distribute that x to the fourth? I think that make life a little bit easier. Distribute x to the fourth. You get x to the fourth minus 2x to the fourth over x plus 1. Does that look a little bit easier to the eye? Now, can I just derive that by itself? And then this piece, could I use product rule? No, not product rule, quotient rule. Okay. So, we're going to derive this. That's simple. 4x to the third. Yes! Don't you wish it was all that easy? Now, minus, this is going to be a really huge chunk of change. Do you understand? It's going to be x plus 1 squared on the bottom. So we have a quotient rule. Quotient rule states, oh, do you see this 2? Could I just yank out the 2 real quick? Is that okay? Take the 2 out of the top. Just put it out front. Derive everything, leave the 2, and deal with it later. Just makes everything a little bit smaller. Okay. So to derive, we're just deriving this piece now. So x to the fourth is 4x to the third. Leave the bottom, or g of x. And then don't forget it's minus. Leave the top, which is x to the fourth, and derive the bottom, which is 1. Hopefully that looks okay. Yeah. Don't worry about simplifying that yet. Don't forget that's a minus. So it looks like we have now, let's go this way, we still have 4x cubed minus 2 into parentheses. We're going to have to distribute the top here. Looks like it gives us 4x to the fourth plus 4x to the third. And here it's minus x to the fourth over leave the x plus 1 squared. You don't want to FOIL the bottoms out, usually. And if we keep going, let's continue this to the other side here. We got still the 4x cubed minus 2, and that's times, and you can combine the x to the fourth, gives you 3x to the fourth plus 4x cubed over x plus 1 squared. And I think I'm going to leave it there. I technically could, what could I pull out of here? I could pull out x cubed, but would that cancel with anything on the bottom? So you really don't have to pull it out. It'd be good to notice that because there's something we'll learn in the future where that's highly important. But you could pull out an x cubed, but that's not going to do anything. It really won't do anything here because, I mean, could I get a common denominator? Yeah, but wouldn't that be annoying how big this is? You don't want to deal with common denominator. It'd take way too long. So this looks like a good answer, except x squared or x cubed could probably come out next to this too. So let's claim this as our answer for now. That looks like a goodie. Alright. Now, if you would have done product rule, you might have got an answer that looks completely different. If you would have done the product rule, you could have went a whole different route and the answer could look completely different. And then you have to do a whole bunch more simplification to find the answer. That's what stinks. But let's leave it like that, but you could possibly, in the end, at some points have to do more work. Now, look at this one. Could I FOIL that out? Could I FOIL these two and then FOIL this answer by that? Or distribute this? Yes. That probably would be easier because let me show you what would happen if you didn't do that. But let me show you what the product rule of doing this is. Basically, product rule can work 3, 4, 5 times. I'm going to show you. We're not even going to finish the problem. I just want to show you how it sets up, because you'll understand why you don't want to do this normally. Derive the first. Leave the second and the third. Are we okay? What do you think we're going to do next? Leave the first, derive the second. Leave the third. And then another plus, and you leave the first, leave the second, and derive the third. Hey, look at this. I gotta do all that, I gotta do all that, and I gotta do all that, and then combine it all. Wouldn't it have been easier just to do it all one time at the beginning and derive that nice polynomial? Okay, it would be easier to multiply it all out to start with instead of doing each piece and then dealing with all this. Okay? Do you see how you're going to do way more work in the long run this way? This is not done. This is just what you could do and find yourself spending a lot of time messing with. Got it? I would have foiled that, distributed and then foiled. Okay. Next problem. That was just a watch out. Think about if there's more than one, more than two, you can do 3 times. You just got to do the first, the second, and the third. This one's actually pretty easy. 52. The derivative. It's a product rule. Derivative of sine is cosine. Leave cosine x. And that's a plus. Leave sine. And what's the derivative of cosine? Negative sine. X. Sorry, sometimes I don't say x, but I assume people know that. If I simplify this, I'm left with cosine squared x minus sine squared x. Now, that is my answer, but let's simplify that. Some people think this is 1. No. Cosine x plus sine x, cosine squared plus sine squared, that's 1, not minus. Got it? But what this is, it is a double angle formula, which I always forget myself what they are. But this is actually cosine 2x. I told you you might need to know your double angles. That's the only one you kind of need to really kind of watch out for, all the double angle formulas. I'm not good at it myself. It doesn't happen very much, but that's the one thing that I would tell you could pop up. Okay?